Alright, so here is a video on calculus stuff we did this year that you can do on a calculator. I think this is pretty useful to know. Don't get mad at me for not showing it to you earlier, because when you take calculus in college you have to learn the real way to do things. Using a calculator is a great way to check. So one thing we did early in our calculus career, after we did limits, we learned how to find the derivative or slope, instantaneous slope at a point, and there's two different ways to do it. So one way is to hit math, right there, right? Hit math, and then it's hard to read. Wow. Okay. And then you go down to number 8, which is n-deriv, and you click it, and you get this crazy looking thing. This is so bright. Okay, so I'm going to have to tilt it. There we go. So you can tell it what letters to do. D over dx, so take the derivative of, and you can do anything crazy, right? X squared minus 6x, right? And you want that as x equals whatever. Let's say as x is 3. And it'll give you an answer. You can see it over here. Slope is 0. Wow, that was weird. Let me try that again. Let me change that to a 2. Okay, the slope when x is 2 is negative 2. Okay, so you can, that's one way to do a slope. The other way is from a picture, and that is to graph the function. So we go to y equals, let's get something more interesting than 3x plus 1. Let's say y equals x squared minus 5x plus 3. Right, so we got that equation. We graph it, and we can find the slope anywhere. Like if I found the slope when x is negative 2, right? You go, first you hit second trace, right? And we go down here to number 6, dy dx, and I can just type in an x value. When x is negative 1, see how it shows up there at the bottom? Hit enter, and you find the slope. It says the slope is negative 7. dy dx is negative 7. So it has a slope of negative 7 there. You can do that two ways. Alright, so example 1, let's try one of these each different way. Okay, so this is, you could do it the old-fashioned way and find the slope and plug it in, but so I'm going to type this in my calculator, this right here. Yeah. So I'm going to do part A with the first method, where I hit math, right? Hit math, go down to n-deriv, which is number 8, type in d over dx, derivative, and then I'll type in this equation, 3x squared minus 2x plus 7, and then at x equals negative 1, and I can hit enter and see my slope is negative 8. Okay, so negative 8. Okay, and then you can do it again, find the slope of the tangent line. This is an equation we didn't even learn how to do in here. And what's cool is your calculator can do it. We're going to do this the graphing way. E to the x, you can see that button right there, right above natural log. So I can do e to the x plus 3, and I want to find the slope, so I hit graph. If I want to find the slope of this crazy line at x equals 2, all I got to do is do second calc. I could do this on the other one, by the way. dy dx, and type in 2. Enter. And it says right here the slope is, in this directions, we'll say go to the nearest, what are we going to go to? Nearest, let's see, thousandth, because your homework will be like that. So my slope is going to be 7.389. That's the slope there. So you can do it on any equation. In college you'll learn how to do those by hand, but we didn't do that this year because we had a crazy year. Alright, something else we can do is we can actually graph the tangent line. So we did that by hand sometimes. We found the tangent line, we found where it was, Now we're going to graph it on there. Okay, so let's look at these instructions here. Here's how we're going to do a tangent line. We use derivatives to find it, so I type this equation, the x squared minus 6x plus 1. In my graph, I typed it in y1, so we're going to hit graph, and there it is, parabola. Now I can not only find the tangent line, but I can draw the tangent line by going second program. See program right there? I'm going to hit second program, which is draw. Brings up lots of points, but you can see number 5 there is tangent. And I just have to type in the x value I want the tangent line to be. So this one says x is 5. So I'm going to type in a 5, hit enter. Not only does it find it, but it draws it, and it finds the equation for it. You can see I can hop between, oh man, let me do it again. Now it's good practice, right? Oops, second draw, tangent, 5. If you look at the y part, it tells you the equation of the tangent line. It's 4x plus negative 24. So 4x minus 24. That's the equation of the tangent line. And it said draw a sketch. So, a quick sketch of what that looks like. We got a parabola, kind of goes down like this. And when x is 5, 1, 2, 3, 4, 5, we got this line here, that tangent line right there, which is y prime. If that one's y, this one's y prime, equals 4x minus 24. So that's pretty cool. Similarly, we can do it with this guy. So let me pause, do that real quick. Okay, so I typed the x squared plus 4 over x, my y1. I hit graph, and it graphs this crazy equation. Irritating those were to graph by hand. And then I want to find the slope of this line at x equals 1, so right about there, in the tangent line. So I'm going to go second, draw, tangent, and I'm going to type in a 1. And not only does it find it, but it draws it, and gives you the equation. The equation is negative 3.00004x plus 8. Now, that's trying to tell you y prime, because this is y, equals negative 3x plus 8. Turned out to be a pretty nice answer. My graph of it, I just sketch a quick graph. We had one of them do this, right? And then the other graph kind of go like this, boom. And then this tangent line went down like this. Okay, so there's your equation of the tangent line. Pretty cool stuff. So something else we can make our calculator do for us is graph derivatives. I type the original, this is for example 3. I type the original into y1, and then in y2 I'm going to make it find the derivative. I don't know if you knew you could do this, but right here I can hit math while I'm on y2. I go down to n deriv, and then I'm going to do the ddx and type in that equation we just did, right, plus 3x minus 1, and then I'm going to type in x. So I want the whole thing. I don't just want it at one point, I want it to happen for the whole thing. So I'm going to find the derivative of the entire thing. That's why you could type it in. If you have an older calculator, you'll type it in like this. Then we hit graph, go to, oh shoot. Try that again. I had a minus sign instead of a negative. And there's your equation of the original, and here's your equation of the, what do you call it? Derivative. Now it takes a while. See, it's thinking because it's got to calculate every line. And it makes sense that if I had a cubed for my original, I would have this parabola for my derivative because it goes down by one exponent. And that's the equation. And I want to sketch that. I think I can trace and I can hop on here. Yeah, so you could hop on at any point and find the slope of the original line. But yeah, I'm just graphing this graph, so I could graph it more accurately, but I'm kind of trying to get this done in 15 minutes so I can beat the clock here. Okay, let me draw this and then we'll come back for number 2. Other thing I forgot to show you, I didn't have to type all that in again. You can actually use your y1 as a variable. I don't know if you knew this, but right here, you know how that's stored as y1, the first graph? You can go into vars, which is short for variables, scroll over one to y variables, hit enter on function, and grab y1. So you could do the exact same thing, and you can use your y1 in your y2. So there's your original, and then remember it's got to think for a while and calculate your derivative. And it should make sense that on my graph, anywhere the original graph hits a 0 is where there's a max or a min. Because there's a max, there's a min, or sorry, min and a max. You can also do this with all sorts of crazy equations like number 2. So I'm going to pause, do that, show it real quick. This one I can do it. It says use radian mode. So if I hit mode, it's in degrees. I can hit radian. And I don't know if you knew, there's a zoom for trig. You go right down here to zoom trig, and it'll graph my original. You know what sine curves look like. You can get an equation for the slope of sine curves. Once again, we didn't do that in class, but we could have. And yeah. So anyway, that's that one. I'm going to do a quick sketch and move on to the next one. The stuff we were doing before, just recently, integrals, and you can make your calculator do the integral. You hit math, and if you look down at the bottom, number 9, function integral, that's what that one is. I can put my lower limit 2, my upper limit, 1, my upper limit 5, and then I can type in my equation, x squared plus 3x minus 1, and put dx, and then hit enter, and it finds the area under the curve. Isn't that awesome? Cool stuff, huh? I can do the integral with sine. I'm still in radians, and I hit enter, and it has a nice area of 2. Kind of cool, right? Nice stuff. Here's a different way to find an integral, which I showed some people in class. A good way to check your answer is you can do it with graphing. So if I type that exact, and next page is where I actually do this. If I type that exact equation in my y1, okay, so I typed the x squared plus 3x minus 1, and I go to graph it, zoom 6, so I graph it, and you know, it's a parabola, right? And then I can find its integral by going second calc, and you can see way down here at the bottom is your integral. And you just got to type in your lower limit and upper limit. So I hit 1, enter, and then 5, enter. And it shades the area under the curve, and it tells you the answer. It's 73.3 repeating, which is the same answer we got before. Coincidentally, it's the same you would get if you raised the power up 1, divided by the new exponent, plugged in a 5, plugged in a 1, did all that good stuff. And you can do it again here on sine. It's just cool because it shows you a picture, and I like that. Okay, so on this one, same deal here. I can type it in. Just make sure you do zoom trig, which is number 7. And then you get a nice looking picture. So we got our trig function. It's going to find the area underneath the curve from 0 to pi. Once we do that, second calc area, enter. We'll go 0, enter, pi, enter. And it came out with 2 is your answer again. Alright, so we'll do the last thing, which is the last thing we did in calculus, and that's find area between two curves, which is kind of nice. Alright, so this one I'm going to enter in my 2 equations as y1 and y2. Then I'm going to find the intersection points. I'm going to pause and do that. I do that by looking at the graph and then going second calc intersect, which is 5. First curve enter, second curve enter, and then you just scroll near it. Okay. So this one hits at x value 2.56. Now the next thing we're going to do in y3, we're going to figure out the top line is my y2, the bottom line is my y1. I'm always do top minus bottom. And then I'm going to turn off those graphs and do my integral I just did from the graph a second ago. So here we go. I hit vars, y variables, function, y2 minus vars, y variables, function, y1. And I go and turn these other 2 off. Boom, boom. And then I look at the graph. I turned them off by hitting enter. Look at the graph, find the area between those 2 points I found.